In this class, we're going to take a look at sequences, and a sequence is just a list which is ordered, so an ordered list of objects, and normally those objects are numbers, so it's just basically a list of numbers where each number in that list has got like a placement within the list, so the first number, second number, the third number, so they've got a certain order, and they've got a certain order because they follow a certain rule. They've got a pattern, but the pattern is dictated by an algebraic rule, and we'll talk about those rules in another class, in fact in the next class. This class today is just really an introduction to sequences, just to get some ideas going, just to feel our way into this topic. So you get many different types of sequence. We're going to focus on a couple of different types, and let me just start by showing some examples. So if you take a sequence where, for example, your first term is the number 3, and then you're adding 3 every time, so the next one is 6, and then 9, and then 12, and then 15, then that would just carry on forever and forever like that. So the kind of rule, the kind of general rule there, I guess, is that we're adding 3 every time. So we're going to look at this a little different in the future in the next class, but for now let's just say that's fine, okay? Let's just say that we're generating these numbers by adding 3 to the previous number to get each successive number. Taking another example, let's say our starting number was 5, and this time let's multiply by 2 every time. So to get the next term, we're just going to multiply this term by 2. So 5 times 2, so we get 10, and just timesing that by 2, doubling it basically every time to get 20, and then doubling that one to get 40, so just multiplying by 2 every time. So again, that would just carry on sort of indefinitely, and the kind of general rule we used there was to multiply each term by 2 to get the next term in the sequence. So these are actually examples of particular types of sequence. So this guy here is called an arithmetic sequence or an arithmetic progression, and we're going to look at those in particular in a subsequent class. We're going to get into detail on those, but it's just one where basically you're generating each term by adding a number. You could be subtracting, it's either add or subtract, and that's how an arithmetic progression works. This guy is called a geometric progression, and a geometric progression, or I'm saying progression and sequence kind of mean the same thing in this context. So this is a geometric sequence or progression where you're getting each term by multiplying by some common ratio. So you're you're multiplying each term to get the next term, and that is multiplying by this common ratio. And the common ratio can be a fraction. It doesn't have to be a whole number like the one that I've got on there. So arithmetic sequence, arithmetic progression, or geometric sequence or progression. And we're going to look at those in detail, like I said, in a further class. Take a third example. If I say the sequence 7, 1, 2, 11, 3, what do we think about that one? How are we generating those terms? Well, I've got no idea because I just made that up. So that's not a sequence. It's not a sequence because even though it's a list of numbers, they're not ordered in any way. There's no pattern to them. There's no way for us to generate a general rule about how we get from one number to the next, unless I've been very fortunate and somehow in my head, made up a rule to generate these, which seems very unlikely. My brain's not that good, unfortunately. So this is just random. So that's an example of a list of numbers, but it's not a sequence. It doesn't comply with our definition of a sequence where the numbers are in order and they're following some general rule or pattern. So as we move forward with this topic, we're going to focus in on these two guys in particular, and we're going to start to ask some more questions about them. So for example, let's say that we carried on with this sequence, we keep adding 3 every time and we get bigger and bigger and bigger numbers. What if I wanted to know what the 27th number was, or the 50th number, or some number way down the list of numbers? Do I just need to keep adding 3 every time? How can I generate a rule that allows me to jump to certain numbers in the sequence? So that's going to be one of the big questions that we ask about both of these types. And then these were examples where obviously these are just getting bigger and bigger numbers, but can we find examples where there's different types of behavior? Can they, for example, go positive and then negative and kind of alternate in that way? can they get closer and closer and closer to some number, or do they always just go bigger and bigger and bigger, or smaller and smaller and smaller? How does that behavior work? These are some of the questions that we're going to explore in subsequent classes, and the ideas there that we're going to look at are things like, how do we generate a general rule for creating terms in a sequence which are way, way, way down the sequence? So these are the terms, so term 1, term 2, term 3, term 4. So if we were to start thinking about that as term 1, 2, 3, and 4, how can we then find, for example, term 27? So that's what we're going to look at when we try and generate a rule. And then we're also going to look at, well, how is the behavior of some of these functions? So one way we can measure that is that does it hit on some limit? Not function, sequence. Does the sequence get to some limit, some highest number, or do sequences carry on with no limit? That's another question that we're going to explore. Sequences are very important mathematically. They're the basis for what is called a series. And a series is just when you take a sequence, but instead of doing this, you do this. You start adding them all up. So that's a very important object. When you get to sort of pre-calculus and maybe even into calculus, that's going to become very important if you go that far in your mathematical career. So this is really your starting point for getting to that in the future. So like all math ideas, they kind of build up over time, usually over several years, to get to these more complex ideas. So that's just really an introduction to mathematical sequences. If you're happy with that, then just kind of try to absorb it and then move on to considering how you generate rules for making particular terms in a sequence.